Dependent probability. So with the independent probability one earlier, where you have two different events that do not impact each other, like flipping a coin 2 times in a row. The first coin flip does not change the events of the second coin flip. However, let's say you have a deck of cards. You pull out one card from the deck of cards. You don't put it back in, so you started with 52 cards. You now have 51 cards. That is changing the math. It's changing the probability of you pulling a different card out. So that would be a dependent. The second event depends on the first event. Let's see here. In a class of 7, there are 2 students who are martial arts masters. If the teacher chooses 2 students, what is the probability that both of them are martial arts masters? So, take each event by itself, and you're going to multiply them by each other. So the first time, what are the odds that we pull out the martial art master? Well, we have 2 students out of 7. So 2 over 7. Now, if we chose that martial arts master, how many are left? There's only 1 left, right? And out of how many students are left? Well, we took out 1 from 7, therefore we have 6 left over. Now we do some math. 2 times 1 is 2. 7 times 6 is 42. We could simplify this fraction and we get 1 over 21. A goblet, basically a cup, contains 2 red, 6 green, and 4 blue marbles. If we choose a marble, then another marble without putting the first one back in the goblet, what is the probability that the first marble will be green and the second will be green as well? All right, so 2 events, and we're going to multiply them by each other. The first event, we have 6 green out of 6 plus 2 plus 4, which is 12. So the chances that we get a green, the first pull, is 6 out of 12. The second pull, what are the chances that we get a green again? Well, we pulled 1 green out, so we only have 5 left. We also pulled out 1 marble, so we only have 1 marble, we have 11 marbles left over. Do some math. 5 times 6 is 30. 12 times 11 is 132. And you could simplify that. You could divide both by 2 at the very least. But I do believe you can just type this answer. 30 over 132. Let's check that. And there we go. Okay, there's a lot here to this question. Basically, we have 2 different ships that are fighting each other, okay? And they're shooting cannons at one another. Captain William, so let's see here. We'll call this one Captain William, so it's CW. And then Pirate Emily, we'll just call P for pirate. So Captain William has a probability of hitting the pirate ship 1 out of 3, assuming it has not been hit. The pirate has a chance of hitting the captain's ship, Captain William's ship, 1 out of 7, assuming this ship has not been hit yet. If either ship has been hit, they always miss. Okay? So the question is, if the captain and the pirate each shoot once, and the captain shoots first, what's the probability that the captain hits the pirate ship, but the pirate misses? Well, this back part right here, the pirate misses. It will always miss if the captain hits. So that's a guarantee, if the captain hits. And what are the chances that the captain hits? It's 1/3. So this captain shoots first, 1/3 chance it hits. And if it hits, then this one will never, ever have a chance of hitting back. Or missing. It doesn't matter. It's a miss every single time. So the chances here are 1/3. In a class of 6, there are 2 students who forgot their lunch. If a teacher chooses 2 students, what is the probability that both of them forgot their lunch? Like the first 2 questions. So we are trying to get the ones that forgot their lunch. The first chance we have is 2 out of 6. 2 kids forgot their lunch out of 6. We're going to multiply that by what is left over. There's only 1 student who forgot their lunch left over out of a possible of 5. And now we do some quick math. 2 times 1 is 2. And 6 times 5 is 30 for 2 over 30.